The following is a video over 2.2, and this is definition of limits. A limit is the most fundamental concept that we talk about in calculus. And the first way we want to talk about this is the graphical approach. Graphical approach. We'll start to do them algebraically, but if you kind of understand the graphical approach, hopefully the algebra one kind of makes a little sense to you. So I like to start this off with a little analogy, kind of the way that I think about limits. And that is, I'm going to draw a little picture here of my room and a little picture of Mr. Sorrells' room. So here's my room. This is room 106. And Mr. Sorrells' room is room 107. And my room I like to call the math party. Okay, that's what we like to do every day. Is we like to have a math party. That's what's going on in room 106. Here's the door. Here's Sorrells' door, and there is no math party going on. Okay, no math party in Mr. Sorrells' room. Okay, and so if I were to draw the hallway, so here's the hallway. Here's where I stand. Here's where Mr. Sorrells stands, and we watch you guys as you come in from the left side and from the right side. You guys all come in and you approach the math party, okay? And so that's kind of the idea. So as you approach room 106 from the left and from the right, you are approaching the math party, okay, in room 106. All right, so graphically, I kind of want to talk about what this looks like. I'm just going to draw a quick little x and y coordinate plane. I'm going to draw some function f of x, and I'm going to put a some x value here. I'm going to call that value c, and then on that graph, when x is c, we get this y value of l. Okay, and so we have this point here. We have this point c comma l. All right, and I use this notation because this is what all the books use, some x value c and some y value l. So what we do is we go, okay, we're concerned about what's happening on the graph when x approaches c, okay? And if we approach from the left side, so if we come in from the left side and we come in from the right side and we approach this value c, we want to know what y value are we approaching, okay? So formally, if I was talking about a limit, I would say the limit as x approaches c of this function f of x is equal to L, okay? And basically what that means is, as we approach c on the graph from the left and from the right, we want to know what y value are we approaching. So when I write this, c is an x value, okay? And L, the limit value, is the y value, okay? And so we just kind of have this notation that we use and say, okay, given a certain function, as we approach some x value from the left and from the right, we get this as a y value, okay? And so this happens, you know, if the function is continuous, meaning you draw the graph without lifting your pencil, then every point on here has a limit value, but there are some that get a little tricky, okay? So let's take a look at those. Another one that we could have is, let's say I draw a graph like this. All right, I'm going to draw an x and a y coordinate plane, x and y, and I'm going to have some x value c here, and I'm going to just put a little hole right here, and I'm going to call that y value L, okay? So I'm just going to draw some random function, okay, and I'm going to call this function g of x, okay? And so what we're taking a look at is I want to ask the question, okay, what's the limit as x approaches c of the function g of x? Okay, what's that equal to? What's going on? So if I approach c from the left and from the right, I'm still trying to figure out, okay, what point are we approaching? Now there's a hole here, okay? And the hole means that every other point along this graph there's a y value except for at c. However, as we approach this x value from the left and from the right, we are approaching the same y value L, okay? So I can, again, write this limit statement, that we do have a limit at c, okay? So if I were to say this, well, what's g of c? What's the function evaluated at c? Well, and there is no point at c, so this does not exist, okay? There is no point, and so I can't, if I plug in c into my function, I'm not going to get L. But my limit value is L, okay? And then we have a third one, okay? And we've got a couple other times where this works. But I'm going to draw another example of a limit. And so if I draw a limit, if I draw an x and y coordinate plane, and I draw some function, I'm going to call this c, and I'm going to put a point here and make a function go like this. I'm going to put another point here, an open point like that, and I'm going to call this function h, okay, h of x. Okay, I'm going to call this point L, and I'm just going to call this point j, okay? And so here's what I'm going to ask. My question is, what's the limit as x approaches c of h of x, okay? And as we approach c from the left, we get a value of L, okay? And as we approach c from the right, we're approaching a different y value, j, okay? Because these are not approaching the same y value, because they're not going to the same math party, we would say here that the limit does not exist, okay? So we're just trying to determine what's happening on this graph at certain x values. What's going on in the neighborhood? What are we approaching? Okay, we'll talk. This is a two-sided limit where we go from both sides, but we'll talk more about one-sided limits in the next section. So let's kind of take a look graphically at what's going on here. This is problem number 8 in your notes, and what we see here is we have a parabola. Except for here we have a hole at 0 on this parabola, but I have the point down here at 0, 0. Okay, so let's ask a bunch of these questions. Okay. It wants us to know what's g of 0, and this is just asking what's the point, okay? What's the location? So when x is 0, what's my y value? And I have a point here at 0, okay? So g of 0 is equal to 0. This is a point on the graph, so I'm going to write that on the graph, okay? And then it asks us this limit question. Okay, well, what's the limit as x approaches 0 of g of x? So as I approach from the left and from the right of 0, they're both approaching the y value of 1. So my limit value here is 1, okay? So now let's take a look at the part C. Let me change the colors here. It says, what's g of 1? Okay, well, g of 1, excuse me, is just the point 1, 2. Okay, there's that point 1, 2. All right, so if I plug in 1 into my function g, I get a y value of 2, and that's what that's asking me, okay? Then it asks, okay, well, what's the limit as x approaches 1 of g of x? So as I approach 1 from the left and from the right of g of x, I'm also approaching the same value of 2, okay? So basically what this is, guys, you're basically identifying points on a graph, okay? You have limits exist at holes and anywhere where you have a graph, okay, where if it's a continuous graph, all right? So let's take a look at another one. Take a look at number 10. This one wants to know, okay, you've got this function f, you've got these 3 different line segments, and you've got a point here at 2, 2. Okay, but you have a hole at 2, 4. All right. So it's asking, okay, well, what's the function value at 2? What's the y value when I plug in 2? And that's the point 2. Okay, if I plug in 2 into my function, I get 2. So my function value is 2. All right. Then it's asking, okay, well, what's the limit value as x approaches 2? So let's go to our function. As we approach 2 from the left and from the right of our function, what y value are we approaching? And that's 4. Okay. So then the limit as x approaches 4, let's do that one. So this is 3, this is 4. So as we approach from the left, we're approaching 4. And as we approach from the right, we are approaching 4. So the limit value here is also 4. Okay, what about 5? Okay, here's 5. So 5 looks like I have a point at 5, 2. So as we approach from the left, we're approaching 2. As we approach from the right, we're also approaching 2. Okay, so guys, I think this is pretty simple. You just kind of re-watch this video because this stuff is going to pop up all the time. We're going to ask you questions all year long about this. They're pretty easy to determine, but you have to understand what it is that you're doing with limits. Okay, I'm going to do another video of the next couple problems.